Good morning. Thank you for coming today. My thanks go to the chairs who gave me the opportunity to present my paper as a video. My name is Tawsan Sheikh Roho. I am a PhD student in the University of Sfax, Tunisia. Today I present to you my paper entitled Time-Aware Automatic Process View Generation. First we'll look at the general context, motivation and objectives of our work. Next, we'll detail the proposed approach, and finally I'll conclude and give some perspectives. With the advent of open communication infrastructures like Internet, the business-to-business e-commerce market is expected to expand rapidly. Within B2B transactions, organizations collaborate together and form inter-organizational business processes, involving different processes which can depend on different parameters, such as time. Consequently, organizations aiming at providing cost-competitive products are striving to include and to consider the temporal dimension in their processes. Since failing to consider temporal information in process models turn out in high process execution costs, and it's essential to preserve the industrial privacy in inter-organizational business processes. This in turn has led to an increasing demand for innovative mechanisms and technologies that support the time modeling and management in the process life cycle. Our objectives are to well capture the temporal requirement during the business process modeling phase, to preserve privacy in inter-organizational business processes, and to diagnose potential temporal violation of the process model. As a solution, we propose first a BPMN extension for capturing temporal requirement during the business process modeling phase, which we call here specification step. Next, the second step, called time-aware process view generation or APVG approach, which consists in a set of algorithms to automatically generate process views from private processes while considering temporal constraints. The aim of this step is to preserve the undestroyed privacy in inter-organizational business processes. Finally, the verification step is based on the model checking technique to diagnose potential temporal violation of the process model. Let's consider the BPMN diagram of a manufacturing organization depicted here. The process is triggered when a customer submits an order. Then he can check whether the ordered articles are available or not, the activity check availability here. If the ordered articles are not available in stock, the organization needs to launch a subcontracted activity. Following that, the customer is asked for financial settlement, receive settlement, and the goods are subsequently prepared for further shipment. We find here prepare shipment. The goods have to undergo an export handling procedure and a security check. If all checks are fulfilled successfully, the goods are finally shipped and the process meets its end. We first extend the OMG standard business process model and notation BPMN to capture temporal requirement during the business process modeling phase. For that aim, we add the duration and the temporal dependency finish to start constraints. The duration temporal constraint consists in an activity decorator with the minimum and maximum duration values, as shown here. The temporal dependency finish to start denotes that the activity AG should start its execution no later than max D time units and no earlier than min D time units after the activity AE ends. We assume now that each activity of the process model has a duration constraint. like depicted here. Before defining the APVG approach, we need to introduce some related concepts. Let's start by the concept of process view. In business collaboration, we assume that each partner has a private process which is only visible to its own business entities. Nevertheless, external parties have no knowledge about the process structure and internal logic of the private process. So a private process can have many views, each customized to one partner. So why generating business process views? Is first to interact with external parties while protecting private aspects of the process, and second to eliminate unnecessary details needless for their communication. In our work, we consider two ways for constructing views: abstraction and aggregation. The abstraction is to make parts of the process invisible to external parties. For instance, the organization doesn't wish to divulge some private information such as the subcontracting activity, shown here. Also, this organization prefers to hide the delivery details of its private process, since they are useless for the communication with the considerate customer. So, the aggregation can be a useful way. The aggregation is to group some executable activities of the private workflow into virtual activities. So the organization needs to generate a customer process view such that in this context, we are especially interested in considering temporal properties of private processes when building public views. So assisting business designers to automatically generate process views from private processes while considering temporal constraints is still a challenging task. The proposed APVG framework aims to automatically recalculate and propagate the corresponding temporal constraints from the private business processes called private temporal constraints to a corresponding process view, respectively called public temporal constraint. We consider two different operations: abstraction and aggregation. The abstraction algorithm proceeds by adding temporal dependency constraint finished to start to the temporal constraint set of the calculated view. We differentiate between three major parts of the proposed algorithm. First, finding the source set of activities to add the required temporal constraints finished to start. Second, finding the destination set of activities to add the required temporal constraint. And third, calculating and adding the maximum, respectively minimum duration attributes of the finish to start temporal dependency. We come now to the aggregation algorithm. Indeed, it calculates the temporal constraint set for the process view resulting from an aggregation process. We differentiate between two major parts of the proposed algorithm. First, calculating the minimum and maximum durations of the resulting aggregation activity. And finally, adding the required duration temporal constraints to the temporal constraint set of the calculated view. And finally, this is the result of the application of the aggregation algorithm followed by the abstraction algorithm on the motivating example. Thus, our approach ensures the non-disclosure of professional secret and reduces the risk of error while generating business process views. We come now to the verification framework. In this context, we use the real-time model checker UPAL for the formal verification of process views. Thus, as a first step, process views are mapped onto the network of the timed automata as shown here. Based on the generated UPAL models, the second step consists in performing the verification of some properties, such as deadlock freedom. Moreover, our work goes far beyond the simple verification of the structural properties, such as deadlock. Precisely, we ensure the verification of user-defined temporal constraints. For instance, the designer can verify deadline constraints of the public views. By using our verification process, every organization can verify the correctness of the temporal constraints of both its private and public processes. To summarize, in this paper we have first proposed the BPMN extension to capture some temporal requirement of process models such as duration and temporal dependencies. Then we have defined the time-aware automatic process view generation to automatically generate process views from private processes while considering temporal constraints. And finally, we proposed the verification framework to facilitate the early discovery of temporal violations during business process management lifecycle. As future work, we aim at finalizing the implementation of the proposed approach. Then we intend to extend our algorithms to handle a larger set of temporal constraints beyond the duration temporal constraints presented in this paper. Furthermore, we plan to further investigate on the problem of automation of the proposed BPMN extensions through process execution engines. Thank you very much.